Good evening to Engineer Kalpa Velvetigoda, IESL committee members, and fellow engineers. Thank you for joining in this meeting. Let me start the meeting with acknowledging traditional landowners as our tradition. In the spirit of reconciliation, the IESL NSW chapter acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. First of all, let me thank Engineer Kalpa for accepting our chapter's request and delivering this valuable lecture for our members. It is a time now and privilege to introduce Engineer Kalpa to our audience. Kalpa obtained his Bachelor's in Science in Engineering honors degree from the Department of Electrical Engineering from University of Moratuwa. He is a member of the Institute of Engineers, Sri Lanka. Kalpa has over 8 years experience in the field of software engineering in Sri Lanka as well as in overseas. He is the co-founder of the Yuga Invent Private Limited, a company focusing on providing electrical and software services and products to the industry. He is currently working as an independent software consultant, an active contributor to free and open software projects. The presentation topic is biogas as a practical and alternative energy source for domestic applications. Energy is an indispensable consumable commodity in the modern human life on a global scale. With the rapid depletion of fossil fuels, the world continues to try to move away from petroleum-based fuels. Especially in the Sri Lankan context, in the domestic sector, liquid petroleum gas, which is known as LPG, is heavily used, in particular for cooking. With the recent shortage of LPG in the country, Sri Lankans has looked for alternative energy sources, and biogas is one of them. There has been a boom of interest in the subject in terms of awareness, knowledge sharing, construction of units, etc. While sharing general knowledge on biogas as an alternative fuel, this talk will discuss more on the practical aspects of do-it-yourself domestic biogas unit. Let us welcome Engineer Kalpa to deliver his valuable presentation. Thank you and welcome, Engineer Kalpa.
Thank you, Soti. Let me show my presentation. All right, I hope you all can see my screen. Thank you, IESL New South Wales chapter, for this opportunity to deliver this talk. So today we are going to talk about biogas. Biogas as a practical and sustainable alternative energy source for domestic application. Let's get started. A little bit about myself. I know Soti also gave a very good explanation, but let me brief through. So I'm Kalpa Velvetigoda. I'm a graduate from the Department of Electrical Engineering, University of Moratuwa. I graduated in the year 2014. And soon after I joined the industry, I joined as a software engineer at WSO2, which is a leading software engineering company in the country. So I'm an electrical engineer by education, software engineer by profession. I would like to put it that way. It's 2 years after I flew to Singapore, early 2017, and worked there for 5 years, and then came back to Sri Lanka towards the latter part of last year. So since then, I'm based on Sri Lanka. And also, I'm still working in the software industry as an independent consultant. I'm also the co-founder of UK Invent. So UK Invent is a startup helping local and international clients with electrical related consultations. We also provide software products and solutions to industries, especially in the manufacturing sector, to improve the performance of the operations through digitalizations. At my leisure, I like to build things, experiment with things. So this biogas unit is one such project which I carried out at my home. So this talk is all about sharing my experience and the knowledge I gathered throughout the process with you all. Okay, moving on, the very first question is, what is biogas? You might have already heard of the term biogas, so let's see what it is. So first of all, it's a renewable source of energy. So when we say renewable, what we normally mean is that the source of the energy is not depleting over the period of time. For example, solar is renewable, wind is renewable, whereas fossil fuels, it's not, it's depleting rapidly. So when it comes to biogas, the term renewable is in the sense that the source of energy for biogas, which is organic matter, or say it's organic waste, will not deplete. Humans, animals, and our activities will keep on producing the organic matter, the waste. So it's in that sense that we call the biogas is a renewable energy. Biogas is also, although we say it's a gas, it's not a single gas. It's a mix of gases. It consists of methane, carbon dioxide, hydrogen sulfide, oxygen, etc. So if you take a look at the compositions, you can find methane around 50 to 75%, carbon dioxide around 25 to 35%, a little bit of hydrogen sulfide, 3 to 5%, and also water vapor. So biogas is produced in a reaction of bacteria decomposing the organic matter. When we say organic matter, it could be food wastage, kitchen wastage, or the manure from animal, etc. The important thing is these reactions of these bacteria happens in an environment where oxygen is not available. So we call it an anaerobic environment. So this is very important for the proper functioning of this bacteria. Chemically speaking, it's a multi-stage process going from organic matter to biogas. The fermentation of gas is a multi-stage process. I'm not going to go into details here. Let's go on. If you take a look at the global perspective in terms of production and consumption of biogas, you can see that the large number of biogas production is in Europe. This is based on the data from the year 2018. So almost half of the biogas production comes from Europe. We then have China, United States, and rest of the world accounts for around 12.5%. If you take a look at the countries, even today, as with the latest data, as countries, China and Germany are the major producers of biogas globally. And then if we take a look at the consumption data, we can see that the majority of biogas is consumed to generate power, mostly electricity, but then we have like 32.7 for coal generation, which means that it's electricity and the byproduct of heat is also used as a source of power. We can also see that almost 9% is used to produce biomethane. So biomethane, there are other ways to generate biomethane, but the majority of the percentage of biomethane is produced from biogas. Around 90% of biomethane, the global production comes from biogas. So it's a more purified version of biogas, I would say. So as we discussed earlier, biogas is a mix of gases. If you put it through a process to purify it further, then you can eventually get biomethane. Okay, when it comes to biogas plants, so what are the ideal candidates for an industrial plant? We can see that sewage and wastewater treatment plants, solid waste management plants, and hotels are some of the ideal candidates for biogas plants in a more large scale, industrial scale. So if you think about solid waste management, we have a couple of plants operating in Sri Lanka, especially around the municipal councils, where they use the solid waste to produce biogas. We have a very good example at the municipal council of Kadwela, where they have a functioning biogas plant, and they manage the solid waste through that plant. So if we did not have that plant, or if we did not use biogas, the solid waste will end up as landfills and eventually contribute to environmental pollution. So the plan there is like they already have running, and they plan to produce electricity from the biogas produced there. And even today, they are using the byproduct of biogas production, which is fertilizer, as an additional income source to the municipal council, as well as helping the people doing agriculture around the area. When it comes to hotels, we have a very good example at Chetwin Lake. So they have a biogas plant which has the capacity of processing around 500 kilograms of organic waste daily. So that plant is also in operation, and they use the biogas there for the cooking purpose mainly. So I just wanted to highlight some of the industrial plants we have in operation in Sri Lanka. I'm pretty sure there's a lot more. Actually, based on a survey which was done in 1996, it was found that there are around 5,000 biogas plants around the island, industrial and domestic put together. But unfortunately, only around 30 to 35% of them are in operation. So due to various reasons, some of the biogas plants are not operation. And there's a research paper by Professor Ajit Srila from the Chemical Department of University of Moratuwa, titled Biogas, a Review of Sri Lanka's Performance with Renewable Energy Technology. So that describes what or some of the reasons that led to the high percentage of failure of biogas units. You can refer it if you're interested. So talking about the types of domestic biogas units, there are a number of ways we can classify biogas units. There's a certain classification called Chinese method, when it comes to construction, Chinese method, Indian method, etc. But this is one of such classifications. So basically, we can classify the units based on the construction as underground units as well as on the surface units. So underground units is, as the name suggests, everything is underground. As you can see in this picture, these two are underground units. So the first one is the fixed dome type, where you can see that this is what we call the dome. This is where the gas gets collected. So that is more or less fixed, no moving parts there. The second one is a floating drum type. As you can see here, the collector here it's floating. So when the gas collects up, it will go up, and when the gas is consumed, it will go down. And if you take up, if you think about on the surface plants, again there are a number of ways we can construct, but these two I think is important. The first one is polythene tube. It's a very economical, low-cost solution where you have a tube of polythene. You put the slurry here. We'll talk about the components later. And then you have the inlet, outlet, and you can get the biogas produced from here. The second one is the plastic drum-based plants. As you can see here, it's a plastic drum by which we can construct the plant. So in this talk, I'm going to focus more on this type of plants. And also, this is the type of plant which got heavy traction during the LPG shortage in Sri Lanka. If you compare the two types, underground one, of course, you need a lot of work. You need to dig the ground, put the structure, etc. So if you already have a house which is put up, it may be hard to go for an underground plant. But if you're planning on putting up a house, maybe it's a good idea, a good design decision to design a biogas unit underground, which will also save the space on surface. Also, if you have a small farm, let's say you have a couple of cows, goats, etc., you can think of going for a larger biogas plant by which you can use that animal manure as input to the plant, which is a good producer of biogas. Also, if you're planning on putting up a house, you can also consider the fact that connecting your sewage outlet to a biogas. So, as well as human manure, you can use sewage to produce biogas. So, if you direct your sewage lines to the biogas unit, then you can make use of the ways to come up with a more useful outcome. All right, let's talk about the factors affecting biogas production. As I said earlier, the bacterial reaction, it has to be in an anaerobic conditions, which means it happens in the absence of oxygen. So that's very important. And for the digester, again, we'll talk about the components a little later. The optimum temperature is found to be around 30 to 40 degrees of Celsius. And the pH value inside the digester for the best operation should be between 6 and 8. We'll talk about how to maintain this in the next couple of slides. Okay, moving on, let's talk about the components of a plant. So there are two key components. One is the digester, which I'm shown here. So this is where the bacterial reaction happens. And the second part is the gas collector. Obviously, this is where the gas gets collected. So in between, you have a couple of components, which is also important. For example, you have a bubbler here. It's a air bubbler. And then you have a couple of filters, a couple of valves, some outlets, and there's a gas outlet to the stove. Let's talk about each component in a more detailed manner. So the first one is the digester. Digester, as I said earlier, it's where the bacterial reaction happens. So obviously it has to be airtight to supply with an anaerobic conditions. So based on the community, people who have built the biogas units, we can see that there are there are biogas or digesters of two sizes mainly. So for the first one is the 200-liter one, which is shown in the picture here. This one. By the way, you can source these drums from chemical factories. So they are readily available there. And the second type is the 500-liter one. So you might have already familiar with the water tanks. The Apico water tanks, for example, they have the 500-liter and 1,000-liter. So those two sizes are the ones which I have seen in common in the construction of these units in the community. The next point is about pipe sizes. So you can see there's an input pipe. So we call this feeder. This is where you input the food to the digester. And then there's a liquid fertilizer outlet, and also there's a gas outlet. So if you talk about the food inlet, usually the feeder, the diameter, larger the diameter, it's best. But then it should not be too large. For example, a 4-inch diameter pipe for the feeder is good enough. The reason is that when you put solid waste or kitchen waste, etc., it should be we should be able to push it to the bottom of the digester very easily without any clogging. So we can say a 4-inch diameter for the feeder, and for the liquid fertilizer, it's the same concern, but it should not be as large as the feeder. So 1-inch diameter pipe is good enough. And then for the gas pipes, we can use a 0.5-inch pipe. So as shown in the pictures, one can use the PVC pipes like this, or else they can use the flexible gas hose, or even the level tubes is also fine. One other consideration is when you fix the feeder, you have to fix it in such a way that the open end of this feeder is almost at the bottom of the container. The reason is that the bacteria which is responsible for the fermentation of the gas, it is found that they tend to concentrate at the bottom of the container. So if you put the feeder halfway, then your waste might get floated up without getting digested. So it is important that you put the feeder all the way to the bottom, and there's a angle cut here, which allows the food to reach the bottom of the digester. Yeah, the next thing is about the liquid fertilizer output or outlet. So as you can see here, this is where we can get the liquid fertilizer. So liquid fertilizer is one of the byproducts of biogas production. You can get a very rich fertilizer which you can use for your gardening, plantation, etc. So the norm is that we put this outlet at 2/3 of the height of the container from the bottom. So it's 2/3 from here to here. That's the norm we practice. Also about maintaining the temperature. So we already discussed that the ideal temperature is around 30 to 40 degrees of Celsius for the proper functioning of the plant. To maintain that temperature, we can take 3 measures. One is you can paint the entire digester in black, which will absorb temperature, which will absorb heat. Or else you can put a foil around it, a reflective foil, which will contain the heat inside the container. Or else one other approach is you can bury the digester halfway on the ground. The idea is that at night time, it will absorb the heat from the ground, and it will continue producing biogas even at night. So you can use all 3 or one or two of the methods. So that is about maintaining temperature of the digester. The next component is it's the bubbler. So it's basically a simple air bubbler. So one other thing I want to highlight is that you don't need to have sophisticated devices, etc., to build up this thing. Of course, you need to have the drums, etc., but simple things like a bottle of jam can be used uh, for the air bubbler. So this is how basically it's a simple air bubbler we have seen. So it serves two purposes. The first one is it acts as a filter, especially for the carbon dioxide, and also for other residues which are solvable in water. So it's the first layer of filter that our biogas goes through. The second use is that it it supports visual inspection of gas production. Basically, by looking at the bubbler, you can get an idea of you can get a rough idea about whether the gas is being produced, how fast it is produced, something is wrong with the plant, etc. So that's the use of the second component, which is the air bubble. The third component, which we are going to talk about, is the filters. So normally we can have two types of filters, and based on the and you may have these filters in any part of the gas flow as well. I'll talk about it in a minute. So the first type of filter is the ion filter. So the ion filter is basically filters out hydrogen sulfide. So you may remember that we talked about when we talked about the mix of gases in the biogas, we get around 3 to 5% of hydrogen sulfide in the mix. And this has a very bad smell. It's a rotten egg smell, which is very hard to inhale. So this ion filter basically filters out the hydrogen sulfide in the mix. So this is a simple diagram as to how we can build one, and this is one actually in operation. So the idea is that you have the gas in from here, and then you have a reducer valve. You have another connecting pipe here. You have an invert reduce valve, and then you have the gas out. So inside this portion, we can put, basically we need to put iron there. So how we can source iron is that one option is that you can simply get something like this. So this is a dishwashing wool that we are using in the kitchen. So we can get it and stuff it in here. Or else another good candidate is the wastage or the leftovers from a lathe machine. So when you use lathe machine, you can see there are iron coils sort of things that are left over. So those are also a good candidate for the iron filter. So as I said, this will filter out hydrogen sulfide. And over time, we need to replace the filter. So as per the community experience, people who have built the plants, you can run these filters without an issue for like 6 months or even 1 year. And thereafter, you need to replace the filter. So how you know when to replace the filter is that when you use the gas, if you get a bad smell, which means that basically the hydrogen sulfide is not filtered out. So at that point, you can replace the filter. To easily replace the filter, in the construction, we can use a mechanism like this. So this is basically a valve circuit by which you can dismantle the filter, take the iron out and refill and fix it again. So that way you don't have to throw away this entire part, but you can just replace the iron inside the filter. The second type of filter is the water vapor filter. So we discussed that water vapor is also included, or it's one of the components of biogas in small scale, in a small percentage. For that, we can use silica gel and come up with a similar filter like this. Instead of the wire iron, you can put silica gel inside this filter and use it as a filter. So in the community, in some of the biogas units, I have seen this filter being placed at different places. So some people tend to do the filtering after the collector. Some tend to do after the before the collector. So one advantage I see if we do the filtering before the collector is that so after the collector we have the store, right? It will allow the gas to flow to the store without any disturbance. So if you have the filters here, the flow is a little blocked. So we can have a very good pressurized flow of gas to the store if we have the filters at this portion of the setup. Moving on, we talked about the filters. Next is the collector. So that is one of the other important components of the unit. This is basically where the gas gets collected. So the production happens in the digester. It goes through a set of filters, including bubbler, and then it comes to the collector. So we can see two types of collectors. The first one is tire tube collector. It's basically a tube, a large tube. It could be a bus tube, a lorry tube, etc., to which we can collect the biogas. The second type is the floating collectors. I'll talk about the floating collectors in my next slide. So tire tube collectors it's very convenient to set up. You just buy a used tube from one of the tire shops. You patch it up if there's any leaks, and then you just connect the outlet of the or basically the gas inlet to the tube, and it gets filled up. So this option is very cost effective. It's a very low cost solution. And also later when the plant is in production, if you find that you can store more gas, you can increase the number of tubes connected to one another and then line up the tubes, and that way you can easily increase our storage. Also, if you want to apply some pressure, let's say you don't have enough pressure at the store, you can put some weight on top of those tire tubes and the pressure gets applied and you will have a very smooth flow of gas to your store. Talking about the storage, there have been certain efforts to store biogas for a long period of time, let's say for months. So people have tried using LP gas cylinders, for example, and try to fill it up with biogas using compressors and all. But so far, as per my knowledge, what we have found is that you can do it for a certain extent, but then the longer you store the gas, the lesser the flammability of the gas becomes. So if you store it for a week and then try to use it, the flammability is low of that stored gas. And also, especially in the case of trying to fill up the cylinders, they tend to corrode very quickly because of the water vapor content in the gas. So that's the information I have about storing it in the long run. But let's say it's for a couple of days or you use it daily basis, then there's no issue. Okay, the next thing is floating collectors. I can say it's inherently safe. Let's see why. So floating collectors is basically this setup. So you have large drum here, plastic barrel, and you have a small one here, put upside down, and the gas gets collected inside the small one. Right? So the small barrel can move and down inside the large one. So why I say it's inherently safe is that, let's say there's a high amount of gas production and there's pressure buildup. So this one, if you forget the weight of the small barrel, it's free to move up. So larger the amount of gas, higher this barrel will go up, and eventually any excess gas production will bubble out from here when this goes up. So we don't have to worry much. Any excess pressure will be released through this natural mechanism. Okay, so one more thing we have to focus here is that this water outflow. So as I said earlier, inside this large container, we have water, and it's an open water surface. So we have the threat of mosquito breeding. That's a practical issue. So to overcome that, we can put a thin layer of oil on top of the water body. Then comes the question, what happens if more water gets collected? Let's say it's heavy rains and then more water gets collected. There's a chance that this thin oil layer will spill out and get contaminated with the soil. So to overcome this issue, we have this setup, which is basically a water overflow. So at this particular level of water and oil, there won't be any water overflow. But let's say more water gets adds up and the water level rises, and once it reaches this, the excess water will spill out from here. So that way we can make sure that one is that the mosquito breeding will be minimal, and also the risk of oil contaminating with the soil is taken care of. Okay, those are the main parts of the biogas units. To recap, we have the digester, where all the anaerobic reaction happens. We have the feeder here, and then the liquid fertilizer output. Then the produced gas will be taken through a bubbler, which will do some sort of filtering, and then it will go through additional filters, and eventually it will come to the gas collector. And from the gas collector, through a valve. So these purple boxes are valves. Through a valve, you can direct the gas to the stove. Next, let's talk about the stove or the burner. So there are special biogas burners or stoves. I'm not sure whether we have it available in Sri Lankan markets, but in other countries, there are special stoves, especially for biogas. So in our case, we have to modify existing LPG burners. So the modification is, as we may already know, the LPG gas cylinder we have at homes, the gas is at high pressure. So the gas nipple, the gas inlet to the stove, as shown here, in the case of LPG stoves, is very small. But because of the high pressure in the cylinder, you get enough amount of gas to be burnt at the stove. But in the case of biogas, of course, we can keep on adding pressure to the collector, but that has a limit. So because of that low pressure, we need to make sure that enough gas enters the stove. To do that, we need to enlarge this nozzle. You can simply get a drill bit. Some of the nozzles you can just, it's of screw type, you can turn it and remove. But for others, you can enlarge it using a drill bit. So that's one of the modifications. Sorry, the second modification is that you might have seen that in stores like this, there are certain holes to get oxygen from the atmosphere. So the LPG together with the oxygen from the outside will get burned. But in the case of biogas, we already have certain amount of oxygen already in the mix, so we don't need any additional oxygen from outside. So to make sure that, or to make sure that the gas gets burned properly, we have to close these additional inputs to the stove. So those are the two modifications which you can do to make an existing LPG gas stove compatible with biogas, to be used with biogas. Okay, now we talked about the components of the biogas units as well as how to do the necessary modifications for the stove. Let's talk about how to start a unit. So we talked earlier about what is the input to the biogas production, that is the organic matter. It could be kitchen waste, it could be sewage, wastewater, animal manure, etc. But there's a process before feeding the digester, so that we call starting of a unit, which means that from day zero itself, it is not advised to put waste material to the unit. So there's a starting process, and after the unit is started only, we can keep on using the system. So to start the unit, what we need is cow dung. So we can also use other animal manure also, for example, manure from goat. But it is found that cow dung has cow dung is more suitable in terms of the bacteria growth. And then we need water. When it comes to water, it is not advised to use rainwater because it's more towards, it's a bit acidic. And also it is not advised to use tap water, which is chlorinated water. So what we can do is we can use tap water. We can collect tap water and keep it aside for 24 hours or so. And after that, you can use it for the slurry. So what you need to do is you get cow dung, which is the raw form of it is the best, and then you mix it with water with a proportion of 1:1, and then you make a slurry out of it. It's best if you can filter it also, but it's not a must. And then using this slurry, you have to fill in the digester up to 2/3 of its height, which means that up to the liquid fertilizer outlet, you need to fill it in. Now, if you use a 200-liter digester or even 500-liter digester, 2/3 of its volume, it's a bit of, you need to be a high volume of high amount of cow dung. So if you cannot produce it in one go, or if you cannot find it in one go, you may take 3 to 4 days or to find the cow dung, and then you can keep on adding the slurry to the digester. But it is not advised you keep like a weeks apart. Okay, so let's say now we have filled our digester, 2/3 of it, 2/3 of it with the slurry, cow dung with water with 1:1, 1:1 proportion, and then over a period of time, normally within 14 days or after 14 days to 21 days, in that time frame, we can see that the gas is produced. Okay, if you have the bubbler already in place, you can see that there are bubbles coming out. Or if you have the entire thing set up, including the collector, you can see that the gas collector fills up. But we need to do a small test here. That is, we need to wait until the continuous flame is there. So what we normally do is, let me play this video to understand it properly. So this one, in this particular setup, we don't have the entire thing set up. We have up until the bubbler. So this is the gas inlet and this is the gas outlet. What we do is we light a match and then try to ignite the gas outlet of this bubbler. Okay, as you can see, we can see a continuous flame here. So what tend to happen is, let's say at day 14, when you try to ignite, it will ignite, but then as soon as you remove the match, the flame will die out. That's the initial behavior. But you can keep on trying. You try the next day, the day after, etc. And eventually, normally between day 14 and 21, you will get to a situation where even after you remove the light or remove the match, the flame continues. So that's where we say that the unit is started. We are good to go. Okay. And that's the point where we can gradually increase the, or we can start feeding food to the system. One optional thing you can do to speed up the process is that if you have access to liquid fertilizer from a functioning plant, you can get those liquid fertilizer and then add it to your plant. A thing to make sure is that in the transportation, since it's anaerobic, you need to make sure that whatever the container you're using is it's in anaerobic conditions. So this will speed up the bacteria growth in your plant, because in the liquid fertilizer from a functioning plant, there's already a bacteria concentration in the liquid fertilizer. So it will just grow in your new base and help speed up the things. This is important. After the plant is started, we need to increase the food input gradually. We can say you can start with 500 grams of kitchen waste a day, and then over a period of time, let's say 3 to 4 weeks, you can go up to, you can keep on increasing. Actually, it's more like a trial and error also, because it's not that we cannot say that everywhere you have to follow it. It's based on the quality of the methane or the gas composition that is being produced in a digester. But as we discussed, the bubbler is a good visual indicator as to how your digester performs. So you can put some amount of food and see whether there's an increase of the frequency of the bubbling. If it is, then you can try increasing small step at a time. So once we have everything okay, this is one of the videos where we demonstrate the biogas, cooking from biogas. So the stove modifications, everything is done. As you can see, it's a very bluish flame, just as we get in the LP gas. Okay. Moving on. Okay. Next, we talk about what is good and what is bad for the digest as foods. So earlier we talked about we can use organic matter, but when it comes to a small scale biogas unit, as we have been talking about in the domestic scenario, we need to take note of these things. So vegetables, fruits, meat, and periodically, this is optional. Cow dung, it's a good input to the digestive. So vegetables, you can put it in the raw format also. But when it comes to fruits, too much fruit is also not good, because it will tend to make the slurry in the digester more acidic. Then we need to precautions, or we need to make corrective actions to make the pH to rectify the pH value. And when it comes to meat, also, for example, you can put the leftovers in the food preparation also. For example, if you take fish, we take out certain parts of the fish before cooking them. So those things you can put it in the digester directly. Now, this is especially with meat, that is good for a well-seasoned digester, not at the very start. So at the very start, you can start with rice as in cooked rice, a small amount of fruits, etc., and keep on increasing. But let's say after 3 or 4 weeks of time, when your system is mature, you can dump meat, etc. So in the do nots, basically, we should not put any hard seeds. For example, rice, as in the raw format. Also, seeds of fruits, for example, seeds of the mango, right? Those hard seeds we should avoid putting to the digester. They will eventually get digested, but then since we have a very limited space, it's just a 500 liter or 200 liter. We don't want to pile up the food which will take a longer time to digest. One another do not is the tea leaves, okay, and then coconut powder, and also paper. So those are the not so good foods for the digestion. Next, let's talk about how to feed the plant and liquid fertilizer. So this is about after you have a very seasoned digestion. Let's say the starting process is okay, now it's functioning properly. So the norm is like for a 200 liter unit, when I say 200 liter unit, I'm referring to the digester size. So the digester is made up of a barrel or a drum, which is of the capacity of 200 liters. So the norm is like we can put kitchen waste of 1 kilogram daily. So another thing is that it is not a must to feed the system daily. That is not necessary. So if you don't have food waste for a day or two, you can safely skip it. And then for some reason, if you have excess food, you can put in, but then you need to be extra precautious because a lot of food might make the slurry acidic, which will affect the pH value and then eventually affect the biogas production. Okay. So if you have excess food, maybe you can put it in the refrigerator and then day by day you can add it to the digester. So every time we put the kitchen waste, we can also put water. Okay. So water is also gets used up in the process, so we need to put fresh water. So the norm is it's a 1-to-1 in proportion, the kitchen waste to the water. One more thing which is good if you can do is that push the waste down the feeder. Okay, we saw that in our digester we have the feeder which has an opening towards the bottom of the container. But then if you keep adding stuff, tendency is that they will get piled up in the feeder. So if you have any a plastic bottle or something which you can push the food down, that will help. Let me go back to the slides. Yeah. Next is the liquid fertilizer. So we talked about liquid fertilizer as one of the byproducts, which is very good for the, which is very good as a nutrition for the plants. So when you keep adding water with food, eventually the water level in the digester will go up. Right? We started with two-thirds of the volume of the digester, and every day if we add, let's say, a small amount of water, eventually it will go up. So what you can do is you can drain out the water or rather the liquid fertilizer from the liquid fertilizer outlet once or twice a week. Okay. It is not advised to drain it out daily on a daily basis because in the liquid fertilizer there's a certain amount of bacteria, and if you do it daily, they will get washed off. Of course, they will grow again inside the digester, but it will take some time. So um, the advice is that do it once or twice a week. You can open the valve in the liquid fertilizer outlet and use the liquid fertilizer for the plants. When using it for the plants, the advice is that mix it with water, again with one proportion. So one portion of liquid fertilizer, mix it with one portion of water, and then apply to the plants. Okay, moving on, let's talk about the safety of a plant, which is very important. The entire setup, if you compare it with LPG, liquidified petroleum gas setup, the biogas setup operates in a very comparatively very low pressure. But as you said earlier, especially the digester, the operations or the reaction should happen in an anaerobic condition. If there's too much pressure buildup in the digester and eventually in the entire system, there's a high tendency that wherever we have joints, there will be leaks, and eventually the digester will no longer be in an anaerobic condition, which will degrade the rate of production of biogas and eventually even shut down the machine. Okay, so it's in a way important that even though it is low pressures, that we manage the pressure properly. So for that, one can use pressure release valve. So pressure release valves, as seen in air compressors, you might have seen it. So those pressure release valves are for high pressures, but we can do a mechanical adjustment there in the spring, and then use the same apparatus for the pressure management here also. The other option, which is a much simpler approach, is the use of a manometer. So this is basically what I've shown here. So this is a U-shaped tube. You can use the same hose tube or a level tube. You add some water level here and connect this to any point of the entire system. So let's say you connect it after the gas collector. So this is connected to the U-shaped manometer here. So what happens is that because of the pressure of the system, you can see that the water level of this side will go down, and eventually this will come up on the other side. Now let's say there's excess pressure. So what happens is there's too much pressure from here. This water level will rise all the way and get exited from here, from the U-tube. But here we have a collector which is open to the atmospheric pressure. So the water will come all the way up and gets contained in this container. And the excess pressure will be released through the water in the form of bubbles. And when the pressure is again reduced, the same amount of water will come down, making the system airtight again. So this is a very simple mechanism which people are using in the community to make sure that the digester or the entire system is not exposed to high pressures. So you can roughly control the pressure by using different amounts of water in the future. That's about safety when it comes to pressure management and building up in the system. And also there are safety concerns related to environment, especially with the floating type collectors, which we discussed earlier also. One concern is the mosquito breeding, and also the other concern is the oil contamination. If the oil gets spit out of the container. So we already talked about how to overcome these issues. Next topic is about maintenance of a plant. So unlike LPG, so LPG is very simple. You just connect a cylinder to a stove and it simply works. But when it comes to a biogas unit, we need to do a bit of more work. The first one is we need to check for gas leaks. Again, the anaerobic condition. You need to make sure that it's there in the digester, and also the rest of the system. If there's any gas leaks, we will not have biogas collected. So we need to make sure that there are no gas leaks. How you do it is that periodically you can use soap water, apply it to the joints and see whether there's any air bubbles coming out. It's that simple. The second concern is the crust in the digester. So over a period of time, what people have seen is that there's a layer of crust building up on the top slurry of the inside the digester. So the crust is basically food or the waste particles, components which are not fully digested. What happens is that this layer will become so thick that whatever the biogas produced here will eventually not go up and eventually will not reach the collector. So we can observe this, observe the symptoms of this through the air bubbler. If we see over a period of time the production is reduced, it could be one of the reasons could be that there's crust building. To overcome this issue, people are using this kind of a mechanism. It's made up of PVC tube. So basically, it's a U-shaped tube, and you have an opening here by which you can basically rotate it from hand. What basically it does is it stirs the entire slurry inside the digester, which will help to break out the crust if there's any. But in doing so, we need to make sure that wherever we have the joints here, you don't have leaks. So that's very important. Another simple way to reduce the threat of crust is that once a week or twice a week, what we can do is we can get the liquid fertilizer from the outlet and feed it back to the input. You do it 3 or 4 times a week or twice a week, which essentially gives us the effect of stirring. Okay, that will also help reduce the crust building. The third important one is pH maintenance. We discussed already that for the proper production or the proper functionality of the system, we need to maintain the pH between 6 and 8. So what we can do is we can simply get a small amount of liquid fertilizer, use a pH paper and see what the value is. If it is more acidic, we can take corrective measurements such as adding some amount of lime ash. Temperature maintenance, we already discussed how to do it. But if over time, if you feel like it gets exposed to more heat, then you need to take corrective actions. Filter replacement, that is also one of the maintenance tasks. We already talked about it. You might want to do it once or twice a year. The last point is check safety measures. We talked about the safety measures related to the pressure building up. You need to periodically monitor them. Monitor them as in the sense you need to make sure that those measures are working properly. There are no blockages, etc. The next point is how one can determine the size of a domestic plant. So we talked earlier about the sizes of digesters that we see in the plants in the community. The most common types are 200 liter and also 500 liter. So when determining the size of a domestic plant, 2 things come into play. One is the size of the digester. The second one is the size of the collector. When it comes to the digester, it depends on it basically depends on the daily cooking time that you want to achieve from the biogas unit. Okay. A number of family members, it's obvious if you have more, then you need more biogas. Mode of operation is what I meant by that is that how are you going to uh, use different energy sources for cooking? For example, you use a rice cooker for rice, and then for curries you use a biogas or use induction cooker in the combination, etc. So based on that also, which will eventually decide your daily cooking time, we can determine the size of the domestic plant. Okay. So as a norm, we talked about 200 liter and 500 liter. So a well-functioning 200 liter digester, what you have seen in the community is that it will give you a daily cooking time of 45 minutes a day. Right? You can use the digester, or you can use the biogas collected from a 200 liter digester for 45 minutes a day. The next day it will be filled up, provided that you keep on feeding it. So 45 minutes a day. If you go for 500 liter one, it will give you around 1.5 hours to 2 hours of cooking time. So that's what we have seen in the plants which are already in operation, the domestic plants. Okay, this is a very rough. This is to give a very rough idea about the cost of domestic plant. This is what I have to incur when I was doing my one. So I basically, the plastic drum 200 liter in March 2022 cost me 5,000 LKR. And if you go with the tire tube, it will be 500. If you go with small plastic drum, 2,500. Things might have changed a bit now, but this is just to give you an idea of how much it will cost. We also have to incur certain cost for other accessories and components. For example, the pipes, the fittings, especially the adhesives. So to make sure that your joints are airtight, we can use resin-based adhesives. The plumbing material, etc. So this is for my plant, which is a 200 liter one. It cost me around 17,000 LKR. Okay, in March. But that is with the floating type collector. But if you go with the tire tube, I think you can do it well below 10,000 LKR. Also, there are individuals, and I think even companies, who will build a biogas plant for you. So there are people who will come to your house and build it on site, as well as there are people who build the plant at their sites, even start it up, and then transport it to your premises so that you can use your biogas unit from day one. So we have seen certain such services booming up recently. Okay, we are running towards the end of the talk. It's just a simple comparison with LPG versus biogas in certain aspects. So if you think about space, of course, the stove and the connectivity, if you assume it to be the same. So in the case of LPG, you need a very small amount of space just to put a cylinder on. In the biogas case, if you go with the underground one, then it's fine because you still save space on the ground. If you go with on surface type, then it's a little bit of space. Maintenance, LPG, I would say zero maintenance. Of course, even in LPG, you need to do routine maintenance just to make sure there are no leaks, etc. But comparatively, I would say biogas, it's a bit high maintenance. If you compare the cost, I think it is based on your consumption pattern. So if you use LPG for how long can you use a 12.5 kg LPG? So that depends on your consumption pattern. Safety, if you think about the pressure related safety, I think biogas is much safer because of the low operating pressures. Setup effort, there's a setup effort in biogas. Um, but then comes the advantages. So in addition to the biogas production, which we can use for cooking, this unit also provides you the capability to manage your organic waste, your kitchen waste, etc. And also the byproduct, the liquid fertilizer, which you can use for your plants. Availability, it depends. We experienced recently a shortage of LPG in the market. But if you have a biogas unit, then as long as you feed it, it will produce biogas for you and you can use it. Energy density, this actually depends because in LPG, we say that we have around 26 megajoules per liter energy density. But when it comes to biogas, we cannot say for certain because it depends on the composition of the gas mix that you get in the biogas production. But by the experience of the people who are using the layman's term, it's more or less as LPG or slightly better, which means that let's say you're cooking a curry. If you use LPG, if it takes 15 minutes with biogas, it will take 15 minutes or even slightly less amount of time. So that's in layman terms, but energy density, it's hard to define a specific value when it comes to biogas because it really depends on the composition of the gas. Okay, I just listed down some community links. You can, of course, Google or see the social media for help. I just wanted to highlight this Telegram group. There's a bunch of very helpful people there. So if you run into any issues, you can just post it there, and they will help you out. Yeah, references, and I think that's it. Thank you for joining the session today, and also I hope you could get something out of this. I think Suti, we may be able to take a couple of questions if there's any. Over to you.
Yeah, that's right, Kalpa. So it was a very nice presentation, and I think it's very useful for the current Sri Lankan situation as well. Let us invite some questions and from the floor, if anything to be asked. Definitely, Kalpa is ready to answer. There were some people asking for the slides. Yes,
Yeah.
we will provide those.
Okay, sure.
Yeah, we will provide those. So I think if you can send an email or something to our chapter, we will be happy to assist you, please. Also, at the end of the session, all of you, please, we want to take a group photograph by turning on your videos. So kindly stay until end of the session, please.
Hello, can you hear me?
Yes,
Yeah,
please.
we can.
Hello.
Yes, please come forward.
I'm Ratnasiri from Department of Chemical and Process Engineering, University of Tombora, Sri Lanka. Hello.
Yes,
we can hear Mr. Ratnasiri. Go ahead.
Yeah, thank you very much, Kalp, for very nice explanation about the very simply how the domestic biogas reactor is set up. For example, with the present crisis of the gases. So I think you touched very important point very practically, very slowly, right? And I sincerely thanks for the simple explanations, but ISL, I have some request. Actually, anaerobic digestion is the worldwide waste management technology. In the Sri Lankan context, still we have not been able to reap the benefits of this worldwide technology. For example, as Kalpa mentioned, actually that Kaduela plant, that 1 ton organic waste treatment plant, we established. I was there right from the beginning with the UNDP when establishing that plant. That was not the 100% efficient, but it is a kind of thing we expect in Sri Lanka with the technology management with our people. So in the Sri Lankan context, still we don't have a large scale application of anaerobic digestion. So I think we have to move to that direction if we want to resolve this some economic problem as say, for example, in addition to the domestic usage, we can convert into transport fuel. Actually, we can bottle and fill into the gas cylinders and then sell it. There are many options actually. We have not tapped those options because if we are going to set up the large scale anaerobic digestion plant in Sri Lanka, it is huge cost, billion rupees in euro things. So therefore, but my suggestion is Sri Lankan people can fabricate this plant in Sri Lanka, adopting the technology in the European and Scandinavian. So if you move that direction, we have a plenty of waste generated in this country, right? So that is my sincere request. Again, to Kalpa's lecture, I have these comments for your certain things. You told biogas composition, biogas contains hydrogen sulfide. Actually, it is not always. For example, if you generate biogas from the canteen food waste, it doesn't have a because hydrogen sulfide generated from the sulfate. Sewerage waste water, yes, sulfate we have. For example, latex industrial waste water, yes, sulfate we have. So therefore, it's better to have a hydrogen sulfide, I mean the post-treatment, but it is not always must. The other point is you mentioned this activation of anaerobic reactor. Even in that case, cow manure is enough because in the cow stomach is the anaerobic digester. Therefore, when you take the cow manure, they are having plenty of active methanogens. So that is why we use inoculum, very powerful inoculum. In that scenario, you don't need to get another inoculum from the active anaerobic digester. Even in the Kaduela plant, we entirely filled at the very beginning with the liquid. Actually, Janata Action was the company. We filled the entirely with the cow manure and then gradually fed source separated organic waste until get the acclimation. And actually, we produce the electricity also with the small generator. And now they are using generating the hot water. That is the one point. The other point is the reactor you presented is very common in that. That is normally in the RPCO people also develop a similar thing, green gas reactor. And now it is not available in the market. But this reactor can be easily fabricated in the household level. But there are certain inefficiencies. But you remember the amount of gas generated depend on the size and efficiency and everything. There are some rule of thumbs. So therefore, you cannot generate a lot of gases that depend on the active volume. Okay, if you provide the mixing and temperature control and everything. So those things you have to accommodate. But you have very carefully done this your operation of your reactor. I'm very happy to see the results. Okay. So I think people can understand and they can establish this type of reactors. Thank you. But from the ISL, I request think about in the future aspect in the country. Think about how we actually promote this technology to achieve the global context, right? So that is my sincere. Even now, I am in the Scandinavian country actually, coming as a visiting professor. When I'm traveling with my friend with the car, the front buses, they are running with the biogas. You imagine where we are. They are running their buses with the biogas in these countries. So still we are thinking about the domestic level application. That is why I'm talking from there, right? Thank you very much. Okay.
Thank you, Mr. Ratnasiri, for your insights. Thank you for the correction about the sulfate thing as well. Just wanted to highlight the starting of a unit. I mentioned that adding liquid fertilizer from a functioning plant is an optional action, of course. You can go still cow dung also. And I really appreciate your comments. And I'm in line with you that on an industrial level, we can scale it up. And of course, coming from chemical engineering background, you would be more aware about that than me. As you rightly said in this talk, I just wanted to share my experience on how we do it, how we can do it on a domestic scale. Yeah, thank you. Any other comments or questions?
Well, I think a lot of people are leaving. So can you please all turn on the video and we're going to have a screenshot of all of you for our use. So is it, if I ask you, all of you to turn on the video and we can take a screenshot, please? I think only 50% is turning up. Can you please turn on? We want to see your lovely face, please. How are you getting on, Manasi? Manasi?
Yes, I'm capturing it. Yeah.
So how many of they are there?
Yes. Done. Yeah. Thank you all for turning on your video. So we had 2 questions on the chat. If we have time for
Yeah. I will take
quick
that. I'll take that.
answers.
Yeah.
Okay.
Yeah. I'll take that shortly. Yeah. Well, Manasi, if you have done, just give me a tinkle, please.
Yes, we are done, Sati. We can proceed.
Oh, okay. Okay, Kalpa, there was a question. Can you, do you think is it worth investing for a simple electronic pressure sensor to monitor the production? Okay, that was one question. And the second question was, what are the mediums we can use in a bubbler? So
Okay,
that first.
I'll first answer the second question.
Yeah.
So for the bubbler, the medium you can simply use water. So it's a simple air bubbler.
Okay, sure.
Then the first question was, do you think it's worth investing for a simple electronic pressure sensor to monitor the production?
Yeah.
I'm not sure whether we can monitor the production with the pressures. Okay, of course we can. It depends. I'm actually not quite sure. You can do it, but then in a domestic setup, do you really need to monitor the production, or you simply need to use it? It depends actually on the requirement. But on a large scale, industrial, for sure, you may need to use the monitoring for production.
There was a comment from Lahiru. So it worked at the beginning. After about a week, the production reduced and it's not working properly. Okay, he's putting this one.
Okay.
So what is your comment, Kalpa?
Okay, it could be for a number of reasons. The first very common one would be there could be leaks in the system. For one, it could be in the digester, or else it could be in the rest of the part. If it is like from the start, if it is for a week, then I don't think crust would be a problem. But then you can also check the pH value. So if it is acidic, then you need to take corrective actions to bring down the pH. Those are the 2 points I can think of at the moment. Yeah, Lahiru can check on those 2 points, I guess.
Okay, there is another thing from Tivinka Vimala Surya. So some systems generate more carbon dioxide. What we can do to reduce the amount of carbon dioxide and increase the methane. And also he put, how about using the toilet waste for biogas? We could do this at the design stage of the house itself. Is it right? Members, please, if you say practice for all of you to speak up, I would love to everyone to speak up and ask the questions. Okay, thank you. But I'm happy to assist too. Yeah.
Yeah, sure. So to Engineer Tivankar's question, the first one, it depends on the source of basically what type of waste you are putting in. It's not that every waste will produce the same amount of CO2 or CH4, etc. So short answer is depends on the source of, or depends on what type of waste you are putting in. That is about the production. Also, to reduce the amount of CO2, we can use CO2 filters. That is not to increase CH4 production, but to reduce this CO2 percentage in the mix so that we can increase the CH4 percentage. The second one, yes, we can use the toilet waste. There are certain plants, even in Sri Lanka, which uses toilet waste, especially in the setup of underground plants. Yeah, we need to decide and design at the house designing stage, because it's going to be underground. Of course, if you have plenty of space in your garden, you can still put up underground plants separately. But if you're in limited space, then normally it goes at the house designing stage.
I'm sure, Kalpa, you could in the Sri Lankan context, the septic tanks can be easily converted as a biogas plant as well. My understanding is right.
Yes, there are companies who do it for you, like instead of the septic tanks, which we use normally, they will simply use a different kind of a structure. It's just that the structure is different, and
Okay.
will direct all your wastewater and sewage to that tank.
Okay. The wastewater, will it be too much for the septic tank, or it is?
I think how they are using it widely or mostly, it's a mix of things. It's sewage plus wastewater.
Right. Okay.
But to be honest, I'm not quite
Okay.
informed enough to comment more than that.
Right. Okay, sure. But looks everyone is interested on this matter nowadays. All right. So any more questions? If not, we will just wait for a question.
Yeah, I am Anuradha, so I have a question to the
Yes, please, Anuradha.
make some clarification regarding. So once the pressure is developed in the digester, so is a effect to the microorganism? That means once the pressure is goes high, so is it effect to the production of the methane gas? That means for their activity?
To my knowledge, it is not, at least in the pressures that domestic biogas plant operates. But again, maybe someone else who is more informed about that, it's open to comment. Based on my experience, at least in the domestic, it's not.
Right. Okay.
Another small clarification. So even in the TV commercial, it says that some of the detergents used for the toilets, if I say the trade name, this bio, there is a product called bio. So are these chemical have effect? They are marketing that it is biodegradable or something like that. Is it acceptable?
I cannot comment on that specific one, but yeah, chemicals, they may affect the functionality of the bacteria, but that is important if you go for a underground or for a larger setup. The one we mostly talk about today, the on the surface setup, we may not be adding those chemicals as input. Oh, okay. You might be referring to, okay, when I say kitchen waste, maybe you might be referring to the wastewater of the kitchen also, is that?
Yes, kitchen as well as toilet, both.
Okay, toilet also, we, kitchen waste, we normally, when I say we are adding water, it's pure water I was referring to. But of course, you can use water which you use to wash vegetables, rice, etc., but not what you use to wash dishes, which will contain those chemicals. I think it's the same case with wastewater and sewage lines, but to my knowledge, there are other products, again chemicals, which will reduce the effect of those chemicals. So of course, if you're using wastewater, you will end up, the wastewater will contain those detergents, etc., right? And then there are other products, chemicals, which will nullify the effect of those chemicals. But in the case of domestic, when I say water, I was referring to the pure water. Did I answer your question, Anuradha?
Yes. What about the chlorine availability? For example, if you take water from the National Water Supply and Drainage Board, there's some percentage of chlorine available. So
Correct.
is it harmful?
So at the starting of a unit, because we are adding a large amount of water, what we normally advise to do is you collect water from basically the tap water, keep it for a day to chlorine to settle down. Okay, that's at the start of the plant. But when you add water on a daily basis with the food, you can simply use tap water. That is fine. Also, when you add the food, it's better if you can. This is optional, not a must. If you can chop the food and then insert, for example, fruits, etc. If you can cut it into very small pieces and then add it to the digester, that will help.
Thank you, Kalpa. So if there is, I think it's the time now to wrap up. So let me invite our secretary, Dr. Manasi Vijarana, to give a vote of thanks on our behalf, please. Dr. Manasi.
Thank you, Soti. Good evening, Engineer Kalpa Vallivitigoda, ISLNSW Chair, ladies and gentlemen. It is a great honor and privilege to propose the vote of thanks on this occasion on behalf of ISLNSW chapter. Let me first and foremost thank our distinguished presenter, Engineer Kalpa Vallivitigoda, for delivering this informative and interesting presentation. We are grateful for the time and effort you took to share your thoughts and experience with us. I would also like to express our sincere thanks to Mr. Chamila Priyantha from ISL headquarters, Engineer Rasika Gunawardena, and Dr. Buddhi Vijayaratna for organizing all the computer-based logistics on the background. Next, I would like to thank our wonderful audience for your patience and valuable questions. Last but not least, I thank our committee members of the ISLNSW chapter for working behind the scene and making this event a resounding success. Looking forward to seeing you all in our next IESL event. Good night, everyone. Enjoy your evening.
Thanks, Manasi. So the floor will be open for another 5 minutes or 10 minutes. If somebody want to have further discussions or something, you are welcome to do so, please. I think everyone looks tired.
Yeah.
So probably, Kalpa, you would have stopped buying the LPG cylinders from the time you produced this one.
Yeah. So when I was putting up the plant, I had already one cylinder, which I've been using for like almost 6 months now.
Right. Okay.
For me, the
Just
case
to
is it's a mix of energy. So I use electricity for rice, and the rest of it is from the biogas.
Right. Again, there are also now. I'm using a pressure cooker for the as a rice cooker. It is a multi cooker. So they use a very simple technology. The pressure on a normal rice cooker, it continuously consumes the electricity until the rice is boiled and ready to eat. But this cooker is, what does it does is it's work on the pressure. It is a pressure cooker, but it also has a pressure sensor. So when the pressure reaches a certain level, the electricity or the power is cut off. So with this stuff, okay, the power is optimized. So you don't see all the whistling throughout the time and boiling out. Okay, and it is very, very effective one.
Okay.
and it does multiple things as well. The technology is advancing. Yeah. All right, then I think most of the people has left, so we will just close up. Thank you, Kalpa. Then
Yeah,
thank you
sure.
so much.
Thank you, Sodhi.
Definitely.
Thank you,
Thank you,
Kalpan.
Mansi.
Thank you, everyone.
Thank you.
Yeah, thanks
Bye.
everyone. We will catch up again. Bye.
Okay, thank you.
Bye.